As a continuation for kinematics in 2 dimension, this is our part 2. And we will start with projectile. Okay, so what is a projectile? Okay, so a projectile is the trajectory that an object makes wherein the only force acting is gravity. Okay, so these are the types of projectiles. Okay, so an object thrown or projected into the air subject to only the acceleration of gravity. Okay, so when we look at objects that move in both the x and y direction simultaneously under constant acceleration, an important special case of this two-dimensional motion. Right. So the most important experimental fact about projectile motion in 2 dimension is that the horizontal and vertical motions are completely independent of each other. Okay, they do not affect each other. Now, um, the x component of the velocity, which is v sub x, remains constant in time. Also, v sub y is equal to 0 at the peak of the trajectory. At the maximum height, vy is 0. But the acceleration is always equal to the free fall acceleration and acts vertically downwards. Okay, so we do not have an acceleration on the horizontal axis, only the acceleration on the vertical axis, which is gravity. So, if the velocity vector makes an angle theta with the horizontal, which is the projection angle, then from the definitions of sine and cosine functions, we have these figures. Okay, so to solve for the x component of the initial velocity, we're going to be having VO cosine theta. Okay, theta is the angle that it makes from the positive x axis. Okay, and to get the y component of that velocity or vector, we have VO sine theta. So the kinematic equations for projectile motion. Okay, for the x component, this one. So V of x is equal to V sub x. Okay, this is V sub x. And delta x, or the change in the displacement, is equivalent to V of x times time. Since we do not have an acceleration on the horizontal axis, therefore we cannot make use of this second part of the formula. So this will become 0 for the x component. That's why you have Vy is equal to V of y. Okay, and for the delta x on this part, okay, we don't have an acceleration again, so therefore this will be cancelled out, or this will be equal to 0. Therefore this formula will be the working formula for the displacement on the horizontal axis. For the y component, these are the formulas that we're going to use, and we have a constant acceleration, which is negative 9.8 meters per second squared. Okay, now, the speed of an object at an instant is calculated using Pythagorean theorem. And for the angle, we have arctangent of Vy over Vx. Example. Consider a projectile launched with an initial velocity of 50 meters per second with an angle of 60 degrees above the horizontal. Determine the horizontal and vertical components of the initial velocity. So that's just Vx is equal to V cos theta, x1, 50 cos theta, we have 25 meters per second, and for Vy, we have 50 sine 60, or 43.3 meters per second. Example number 4, the projectile. So a projectile is launched with an initial speed of 60 meters per second at an angle of 30 degrees above the horizontal. The projectile lands on a hillside 4 seconds later. Neglect air friction. What's the projectile's velocity at the highest point of its trajectory? Okay, at the highest point, we will notice that Vy is 0 Therefore, Vx is the only velocity or the component of the velocity that we have. B. What is the straight line distance from where the projectile was launched to where it hits its target? So it's asking for the range. Now, this is the illustration of the given problem. Right? So, velocity at the maximum height. So for the velocity at the maximum height, we know that Vy is 0. Therefore, what's left is V sub x. And V sub x is equal to Vox, or Vo here, or Vo cosine 60. That's 51.96 meters per second. And the horizontal velocity all throughout the projectile trajectory is the same or constant because there is no acceleration that affects the velocity along the horizontal axis. Therefore, our Vx there is 51.96 as well. Okay. Next, for the range. So for the range, since this is our working equation, okay, so we're asking, or we are given that the time is 4 seconds, right? So we're going to be using this formula, Vox times time. So that's 207.84 meters. Next, example number 5. An Alaskan rescue plane drops a package of emergency rations to a stranded hiker as shown in the figure. The plane is traveling horizontally at 40 meters per second at a height of 100 meters above the ground. Letter A. Where does the package strike the ground relative to the point at which it was released? Letter B. What are the horizontal and vertical components of the velocity of the package just before it hits the ground? Okay. Now, this is the graphical representation. We have the Vox as 40 meters per second, and the height is 100 meters. So this is our starting point, right? So the solution for delta x is Voxt. So time must be calculated first. Now, to solve for time, we're going to be using this formula, delta y is equal to Voyt plus 1/2 Ayt squared. Okay, since Voy is 0, okay, leaving us with this equation. Therefore, the computed time is equivalent to 4.52 seconds. We're going to take the positive one. Now, we can solve for the range, okay, or the displacement. Okay, so we have 180.8 meters here. Now, to solve for Vx, that's Vo cosine angle. Okay, and that's actually 40 meters per second. Now, the angle that we used here is not given, but we know that the horizontal component is 40 meters per second. Okay, and solving for Vy, we're going to be using this formula for acceleration, right? So final is equal to initial plus 80. Since initial is 0 for the horizontal component, we have our Vy as negative 44.30 meters per second. And that's it for projectile. Thank you.